Again, welcome back to calculus. In these lectures, we are going to learn how to find the derivative of exponential functions. So our main objective is to learn how to differentiate exponential functions. So we are going to start with two examples here. Let's say here they say we should find the derivative of f at x equal to e to the power x minus s cubed. Now, derivative of e to the power x will give us e to the power x. We already covered the power rule, so the derivative of s cubed will give us 3s squared. So that will be our solution. Now we want to find the second derivative, which means we find the derivative of the first derivative, which again, the derivative of ex will give us ex. The derivative of 3x squared will give us 3 times 2 to the power 2 minus 1. So that will be 6x. Second example, we assume g at x equal to e to the power x minus 3s squared. So again, the derivative of e to the power x will give us ex. The derivative of 3s squared will give us 6x. So our answer will be ex minus 6x. Now let's look at the rules. So we start with the limiting. So let's say, for example, here we want to find the derivative of f at s equal to b to the power x. Now, the variable is an exponent. So that's why we call this function exponential function. So using the limiting process, we say the limit h approaches 0 will be f at x plus h minus f at x divided by h. So we know f at x is b to the power x. So this will give us limit b to the power x plus h, because this is f at x plus h, minus b to the power x, because that's minus f at x, divided by h. Now, b to the power s plus h is the same as saying b to the power x times b to the power h, exponent rule, minus b to the power x over h. We can factorize the bx out. So we get bx, b to the power x, not bx, b to the power x, b to the power h minus 1. Again, we do b to the power s is common in these two terms. So we bring it out. Then bh divided by bs will give me b to the power h. Then bs divided by bs will give me 1 minus 1. So here the factor b to the power s doesn't depend on h. As we can see, we can bring the b to the power x out. So we bring it to the front. Then the limit h approaches 0, b to the power h minus 1 over h. Now we can notice that the limit is the value of the derivative of f at 0. So that is what is given here. Limit h approaches 0, b to the power h minus 1 over h will be derivative of 0. Therefore, again, here we say we have shown that if the exponential function f at s equal to b at x is differentiable at 0, then it is differentiable everywhere. And this will give us the derivative of f at s will give us derivative of f at 0 and times bx, b to the power x. So now this will lead us to the concept or definition of number e, which is exponential. So e is the number such that the limit h approaches 0, e to the power h minus 1 divided by h is equal to 1. So our derivative for a natural exponential function always is the same. So the derivative of e to the power x will give us e to the power x. And we can see another example here. So we have if f at s equal to e to the power s minus s, they say we should find the first derivative. So the first derivative here will give us e to the power x minus 1, because the derivative of e to the power s is e to the power s. The derivative of x is 1. Now, to find the second derivative of this, the answer will be ex minus 0. So second derivative will give us ex minus 0 will give us ex. So that will be the conclusion of these lectures. Again, these lectures, we look at the concept of exponential function to find the derivative. And as we said, the major rule here is that the derivative of e to the power x is always e to the power x. So again, see you in the next lectures. Thank you.